All right, 2.9 practice problem. Oh, I didn't start at the main screen. Ooh, okay. 2.9 practice. 88 through 89 evens. Yeah, that P was an accident. Um, and yeah, I'm talking too much. Mumbling, I should say. I was mumbling too much. All right, let's go ahead and go through these problems. If you need to look back and review the mixture problems, go ahead. But we're mainly converting word problems into to math problems. So let's start with number 2, per use. A coin bank that accepts only nickels and dimes contains $9.15. So, we'll keep going though. There are 3 more than twice as many nickels as there are dimes. How many of each coin are in the bank? Okay, let's start with the second sentence because it's a little bit easier. There are three more, three more than twice as many nickels as there are dimes. So let's rephrase it so that we say the number of something equals the number of something else. So the number of nickels, their number, so we got to rephrase it so we're talking about quantity. So the number of nickels is equal to 3 more than twice as many dimes. The wording on this one's tricky. That's why it's important to take it slow and think about putting in simple terms. Just take your time to think about it. That's what I had to do in this case. All right. So that's our first sentence. Our second sentence says the total in the bank contains $9.15. So how do we turn the number of nickels and dimes into dollars? Well, let me make sure I'm in camera. I haven't checked that yet. Boop a doo boo boo. Nope, pretty low. You can only see my eyes. How's that? Woo. All right, let's do our second sentence. So the way we turn nickels and dimes into a total value. So remember, we got to multiply the unit value by the unit quantity, or in other words, we got to multiply the cost of each nickel times the total number of nickels. So let's put it in terms of dollars. $0.05 times the number of nickels will tell us how much money we have in nickels, and we do the same for dimes. Uh, $0.10 times $0.10 times the number of dimes gives us our total value in dimes, and if we add those together, that'll give us our total number in the bank. So if we're talking about totals, in order to get totals, we got to multiply our quantity times our value. Our quantity times our value, in other words, our unit by our coefficient, or our variable by our coefficient. Quantity is our variable, coefficients are our value, totals are what you get when you multiply. Okay, so we got two sentences here, and they each have each variable in D, so we can go ahead and do a substitution because we already have in by itself. So what are we going to do? We're going to rewrite our sentence on the right, but instead of writing in, we're going to write what in equals. And we can see that now this is a problem we can solve because we only have one variable. So let's go ahead and take our algebra steps. So the first thing we need to do is simplify the left, do this through distribution. So you might be kind of confused when you see this. Oh, I got to multiply 3 by 0.05. Well, just think of it this way. What's 1 nickel times 3? How much money do I have if I have 3 nickels? You would have 15 cents. So you can just write 15 cents plus, and then same thing over here. If I had the value of a nickel times 2, I would have 10 cents. Times 10, doo-ba-doo, gotta pause. Not $10, 10 cents. The decimals right there hiding. Rewrite everything we didn't touch. Doo-ba-doo. Okay, we can still simplify on the left. Combine like terms. We can only combine our D terms. What is 0.10 plus 0.10? 0.20 D. Oh, don't forget about the D's. And we're going to rewrite everything we didn't use. Oh, did I do? Wait. Crap, I keep messing myself up with the pause and start. I'm going to have to go back to the keyboard. Anyway, these cancel. This gives us we're left with $0.2 on the left, 0.2D, and we're left with 9 on the right, and then we divide by 20 cents. And you might be able to, there's a couple ways we can do this. One question we can ask is, how many times does 20 cents go into $9? Well, 20 cents goes into each dollar 5 times, and if there's 9 of them, it goes in 45 times. Another way we could ask it is we could move the decimal over, and if we move it on what we do to one side, we got to do to the other, referring to the sides of the fraction. Now we have 90 divided by 2, and you can probably do that one in your head a little bit easier. That would equal 45. But look, the dollar signs cancel each other because they're a unit, so we can cancel it, and we're left with 45 what? D equals 45 from our D over here. Okay, so we know that the number of dimes equals 45, and to figure out the number of nickels, we can plug it in up here. 2 times 45 is 90, and then the number of nickels equals 93. And remember, these values of N and D are the only values of nickels and dimes that'll make both of our original sentences true. That's what makes them special. Question 4. The freshman class treasury has 30, 10, and $20 bills that have a total value of $430. How many of each bill do they have? So let's break down the pieces of information they have. So one value they give us is 30 bills. So we know that there's 30 bills. How do we get to 30 bills? The number of bills is equal to the number of 10, is equal to the number of, what letter should we use? Let's use D for 10 because of decade, and we'll use T for 20. So the number of, we have 30 bills, the number of bills is equal to the total number of $10 bills plus the total number of $20 bills. Now remember, we don't have to multiply by our values here because we're just counting the total number of bills we have. We're not calculating dollars or anything. So, but now we know that it's $430. So $430 is equal to, now we have value, so now we need to multiply the value by the quantity. So value by the number of bills. Value by the number of bills. Okay, so to continue, we need to do a substitution, but we don't have anything by itself yet. So let's use the problem on the left, get something by itself. Let's just go ahead and make D by itself. How do we get D by itself? We subtract the T on both sides. We're left with 30 minus T equals D, and now we can substitute into the right equation. Rewrite everything we're not substituting. All we're substituting is the D here. So we replace that with our 30 minus T, and now this is a problem we can solve because we only have one variable, that is the T. So simplify the right, because there's nothing we can do on the left. Distribute the 10. What's $10 times 30? $300. Another way you could ask that is, if I had $30 $10 bills, how much money would I have? What's $10 times negative T? Negative 10T dollars. And then we didn't touch this 20 over here, this 20T, so it keeps. All right, simplify the right still. We've got 300 minus 10T plus 20T. What's minus 10T plus 20T? That is 10T. And then now we can just get T by itself. What we got to do, we got to subtract by 300, subtract by 300. We're left with 130 equals 10T, and then we divide by 10. I dropped the dollars, but that's okay. We know that T equals 13. So that doesn't mean $13. That just means, what does T represent? The quantity of $20 bills. So we have 13 $20 bills. How do we figure out how many $10 bills we have? We put it over here. We substitute 30 minus 13 equals D. 30 minus 13 is 17 equals D. So that means we have 17 $10 bills. And if we were to add it up, if we have 13 $20 bills, that's $230. If we have 17 $10 bills, that is $260, not 230. And if we have 17, we have $170. Add them up, that gives us our 430. So we know we got it right. Garrett's coin bank contains 500 nickels, 300 dimes. Wait, 500 nickels, dimes, and quarters. Okay, so let's start with that. The number of coins, the total number of coins Garrett has is 500, and to get the total number of coins, we add up our nickels, our dimes, and our quarters. Once again, these just represent the number of nickels we have, the number of dimes, the number of quarters. It doesn't tell us how much value each of these has. Okay, he has the same number of nickels as dimes. That's a sentence we can write. How do we represent the same number of nickels as dimes? N equals D. Great. And the total value of the coins is $72.50. How many quarters does he have? All right, so, and then the last sentence is the total value is $72.50, and we know that to get our totals, we multiply our value by our quantity. So we rewrite our sum up here, but now we give it its value. So 0.05 gives us the nickels, 0.10 gives us the dimes, and then 0.25 gives us the quarters. Now, you're like, this is confusing. There's 3 variables. How do we do that? Well, let's use the bonus sentence they gave us. There's the same number of nickels as dimes. So let's go ahead and make a substitution. It doesn't matter which one we replace with which, so long as we replace the same one in each. So instead of writing 500 equals n plus d plus q, we can write 500 plus or equals n plus, let's replace the d with the n since we know they're equal, plus q, and then what do we got? We can reduce this 500 equals n plus n equals 2n plus q. Okay, so all we did was we made our substitution. We know that n equals d and d equals n, so we can replace the d with an n. That's all we did. And then we just simplified it. Okay, so now we're only working with 2 variables. Let's do the same thing with this bigger sentence. Let's do a substitution for d. Let's replace it with n, just like we did over here. All right, we can simplify this because now we have like terms. So we can do what's 0.05 n plus 0.10 n. That's going to be 0.15 n. Okay, so how does this help us? Well, we have 2 sentences now, and they have 2 variables. So that's exactly what we need in order to move forward. But we can't do a substitution until we get one of our variables by itself. Let's go ahead and get the q by itself up here since it's already by itself. All we got to do is subtract our 2n. So we'll do that. Minus 2n minus 2n. 500 minus 2n equals q. So now we know that q equals this, so we can replace q with this. Okay, it's all right to drop, I dropped our dollar signs. It's all right to drop the dollar signs so long as we remember that, as long as we remember what units we're using. If you're working with a problem with different different values, then you can't do that at all, but it's fine in this case. So let's keep going. So we made our substitution. We replaced q with what it equals up here. And now we got one variable in the problem, which means we can solve it. Let's simplify the right. We got to distribute first. So we got, I'll rewrite, 0.25 times 500. Another way to ask that is, what is a quarter of 500? Since 0.25 represents a quarter of 1. So that would equal 125, I believe. And then what is a quarter of 2? Or what's a quarter times 2 times negative 2? That would just equal 0.5 n. Now we can combine our like terms. We got 0.15 n minus 0.5 n. And then we didn't touch our 125, so that keeps going. And now we just got to get n by itself. Subtract that 125. Mistake. What's the mistake I made? We're about to get a negative number over here. That's not possible. We can't have negative money. What did I do wrong? Right here. I didn't do our decimal points. If we multiply, wait, did I do our decimal points? Something did wrong. Hold on. All right, guys. Took me a while. I figured out my mistake. This is 15 cents. This is 50 cents. So 15 minus 50 is going to be negative 0.35. So So I actually spent a lot of time thinking about that one because it stumped me. Good thing so what I did, so y'all know, I went over to the screen over here and I just started again. That's all I did. If you get stuck in situations, sometimes you just need to take a step back and start over, and sometimes you'll just correct your own mistakes. But let's continue. So over here, we've got 7250 minus 125. If you do some math, and you can use your calculator if you want, because I'm about to. We get negative 52.5 equals negative 0.35n. Divide both sides by negative 0.35, negative 0.35. Use your calculator if you want again, and you'll find that the number of nickels equals, those negatives cancel, equals 150. So we have 150 nickels. That also means we have 150 dimes because of our sentence up here. And if we have 150 nickels, 150 dimes, that's 300 total. How many left over are for the quarters? 200 quarters. All right. I also realized, remember our clearing fractions or clearing decimals lesson? Whenever we get problems like this, we can go ahead and move all the decimal points over twice. That way we don't have to put up with all the little, we wouldn't run into this problem if I had done that. So if you need to go back and watch that lesson on clearing decimals, do that, because next time I come across one of these money problems, I'll do that. I just forgot about it this time. Number 8, an investor has $40,000 to invest in 2 ventures. One yields 8% and the other 13%. He would like to invest as much as possible at 8%, but he wants $4,500 annual return. How much should he invest at each rate? Okay, complicated stuff, but since we're talking about interest and stuff, we know we're using this problem. I equals PRT. So he has 2 different ventures, okay, which means he has 2 different scenarios. So let's go ahead and do that. Write those 2 scenarios out. And what does it tell us about each of them? It says one of them has an 8% rate and the other has a 13% rate. So we can make that substitution. So I replaced our R with our rate, and notice I already made it a decimal. What else does it tell us? He would like to invest as much as possible at 8%, but wants 4,500 annual return. Okay, this problem makes no logical sense because there's no reason that you would want to invest as much as possible in 8 if you know you're going to get 13%. So that's dumb. Other than that, so we're talking about his return. So that's the interest he's going to get. So let's go ahead and separate it. Interest 1, interest 2 with our little subscript so we can tell them apart. And he's also going to invest different amounts. That's this principal. Interest 1, interest 2. And he's going to do it over 1 year. So we know that t is going to equal 1. So if t equals 1, let's go ahead and show you. T is 1, it multiplies everything by 1, which means we have exactly what we started with, so we can kind of rewrite it without the 1 since we know. And the other thing we can do is, since these are being multiplied, we can treat it like a coefficient. So we can write 0.08p1, great. And we can go ahead and do the same type of technique over here, so it's simpler for us. So we can write I2 equals 0.13p2. Okay, so we have 2 different problems here, and doesn't look like there's much we can do to help our situation. Let's read let's reread our sentences. An investor has $40,000 to invest. So that's the principal amount. Principal is what we're starting off with. So we know that combined, he's going to have 40,000 put in together. So that means that our 2 interests, or our 2 principals combined, is going to equal that $40,000. All right, so we've got another sentence there. We also know that his total interest, he wants to be 4,500. So our I's are our interest, so we know that I1 plus I2 is going to give us that 4,500. Now, there are about 4 different ways we could do this problem from here, but the easiest thing we can do is just get one of our variables up here by itself. It doesn't matter which. And then plug it back into one of our littler equations. So actually it does matter which. I take that back. Okay, since we already have since we already have sentences right here, we see that I1 equals that, and I2 equals that. So let's make our substitutions right up here. So instead of writing I1, we're going to write 0.08p1 plus 0.13p2 equals 4,500, and this is helpful because now we have 2 sentences with the same 2 variables, which is what we need for problems like this. So now what we can do is we can get one of our variables by itself and carry on from there. You should know just by looking at it, if we have P1 plus P2, then P1 is going to equal 40,000 minus P2. Now, like I said from the previous example, well, we're about to substitute this P1 over here, but before we do that, let's get rid of all these decimals. So clearing decimals, we find out what's the most decimal places we use, 1, 2. Therefore, we can move 2 decimal places for everything. 1, 2, 1, 2, 1, 2. So what we got is 8P1 plus 13P2 equals 4,500 with 2 extra zeros, which is going to be 450,000. Now we know P1 equals 40,000 minus P2, so let's make that substitution. 8 times 40. All right, we can distribute through. 8 times 4 gives us 32 plus 4 zeros. 32, 1, 2, 3, 4. 8 times negative P2 gives us negative 8P2 plus 13P2 equals 450K. Combine like terms on the left, negative 8P2 plus 13P2 gives us 5P2. And now we just got to get our P2 by itself. So divide by, or subtract the 320K. That gives us 5P2 equal to 130K. And now we divide both sides by 5, and that gives us something P2 equal to. P2 equals 26,000, so if P2 equals 26,000, how much are we investing with P1? So 40,000 minus 26,000 gives us our other 14,000. So P2, what does P2 represent? That represents the amount we invested at 13%. So this tells us we need to invest 26,000 at 13%. We need to invest 14,000 at 8%. And yeah. Question 10. John Baxley borrowed $25,000 for 1 year. He borrowed some at 13% interest and the rest at 15% interest. At the end of a year, he owed that much in interest. How much should he borrow at each rate? Okay, same problem. Start with our I equals PERT, but we have 2 scenarios, so we'll go ahead and write it twice. Okay, he borrowed for 1 year, so we know that the t's will equal 1, and since we're multiplying by 1, we can just act like it's not there. And we know that we have 2 different rates. One rate is 13% and the other is 15%. So we'll go ahead and write them as decimals and substitute. And we can just make them coefficients since we're multiplying. All right, so we got our base equation set up, and now let's read our other sentences. He borrowed $25,000 total, so those are the principals. So combined between his P1 and P2, he borrowed $25,000. And it also tells us that at the end of the year, his total interest was going to be $3,600. So our interest 1 plus our interest 2 equals $3,600. And we know what our I1 and I2 equal from these equations, so let's go ahead and make our substitutions. All right, and let's go ahead and so now we have 2 sentences with the same 2 variables, P1, P2, P1, P2. So we can proceed. If we can substitute, we can only substitute if we have one of our variables by itself. Let's do this one up here. If we wanted to get P1 by itself, we would just subtract P2 from the other side. So let's do that. And now we can do a substitution. But before we do that, notice we got our decimals. So let's clear our decimals first. The most decimal places we use is 2, so we'll move everything over twice. I just used K for 1,000 here, and now we're going to substitute over here. Okay, we got to distribute the 13 through. 13 times $25,000 is going to be whatever 13 times 25 is, $1,000. So $325,000, and then 13 times negative P2 is negative 13P2. We got to simplify on the left. Negative 13P2 plus 15P2 gives us 2P2. Now let's get P2 by itself, subtract 325,000 on each side. And we notice how I've kind of been using this K to represent 1,000. And notice how when I subtracted, we kept the K. If you didn't know we were talking about thousands, this kind of looks like its own variable, doesn't it? And what we did is 360K minus 325K gives us 35K. So this is a unique situation, but basically because we're using it kind of like a unit to represent thousands, we can kind of treat it like a variable and work it kind of like that. You can watch our unit conversion video about that because I kind of talk about using units as variables, but Just know it works in this case because it's a special case. And now to get p by itself, we just divide by 2. What's 35k divided by 2? That would be something, it would be probably $17.5 thousand. But if we wanted to write that out, that would be 17, 17.5, again, 17.5 thousand dollars. So if he invested, this tells us how much he invested at our second interest rate, which was 15%. How much did he invest at the other interest rate? 250,000 minus 17. 5,000 gives us $7.5 thousand. So yeah, another interest problem. Just take it slow, take your time. Yeah, that's all it takes for these problems. Okay, hopefully this one will be simpler. 12. A florist sells roses for $5 each and carnations for $3 each. If she makes a bouquet... Oh, I'm bleeding. Ignore that. If she makes a bouquet containing a mixture of 15 roses and carnations and sells it for $61, how many of each flower should she use? Okay, so let's start with our totals. So if she has 15 flowers, how does she get to 15 flowers? She gets that from her total number of roses plus her total number of carnations. If she has $61, how does she get that? She gets that from the total value or the total sale of her roses, which is going to be the number of roses times their price, which is $5, plus her total income from her carnations, which is the total number of carnations times her price, $3. All right, we got two sentences with the same two variables. We can solve this with a substitution. Let's get one of these by themselves. Subtract a c from each side. We have r equals 15 minus c. And then now, since we have r by itself, we can substitute it over here. All right, we got one variable in this sentence, so we can solve it. Distribute our $5. We get 5 times 15 is something, 75. And then 5 times negative c is negative 5c plus c. All right, we simplify the right. Negative 5c plus c is negative 4c. Now we got to get c by itself. We got to subtract. We have a positive 75 on each side, so subtract it. We have negative $14. Uh-oh, that could be a problem, except for the fact that we have a negative $4 c over here. So when we divide our $4 on each side, it'll cancel out. Can you see my mistake? I made a big mistake. That 3 did not, this 3 right here, I forgot to include it. All right, so 3, negative 5c plus 3 is negative 2c. There we go. This should be negative 2c, and now when we get c by itself, divide by negative 2, divide by negative 2, negatives cancel. This is technically $2. Dollar signs cancel because we can kind of treat those like variables. 2's, negatives, dollars, so we're left with 7 equals c. So that tells us the number of carnations. How many roses does that give us? 15 minus 7 gives us 8 roses. And if we did 8 times $5, that's $40 in roses. 7 times 3 carnations, $21 in carnations. 40 plus 21 gives us our 61 up here. All right, and let's breeze through these evens at the bottom of the page now. 2, 4, 6, 8, and 12. All right, on the left, let's start with number 2. We got 3 over 2x plus 2 times x plus 7 equals 15. Let's follow PEMDAS. Or to simplify the left, do we got it in parentheses? Yeah, but we can't do anything inside of them. Any exponents? No. Any multiplication or division? Yes. Distribution is a form of multiplication. 3 over 2x plus 2 times x is 2x. 2 times 7 is 14 equals 15. All right, combine like terms on the left. 3 over 2x plus 2x. We can't add those unless we have the same denominator. It's technically 2 over 1. How do we give 2 over 1 a denominator of 2? We multiply by 2 over 2. So we got 3 over 2x plus 4 over 2x. If you don't understand what I did to get from this to this, then pause it and think about how we would add 3 over 2 plus 2 over 1. Rewrite everything we didn't touch. Plus 14 equals 15. Combine like terms. 3 over 2x plus 4 over 2x gives us 7 over 2x. Rewrite everything we didn't touch. So, and now we just have our variable by its, we got to get our variable by itself. Subtract by 14. We got 7 over 2x equals 1. What we do, so we got to undo multiplication by 7 over 2. We undo it by multiplying by the reciprocal. cancel, 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 cancel. X equals what we do to one side, we'll do to the other. 1 times 2 over 7 just equals itself because we're multiplying by 1. X equals 2 over 7. On the right, okay, we got to simplify each side. Or, first of all, we want to, it's usually better to get the x's all on the same side. So let's move this x over here. How do we do that? We'll subtract an x from each side, minus x, which gives us 2 over 3x plus 1/2 x minus x plus 5 equals 9. We can go ahead and move the 5 over as well, so we have all the x's on one side. That's okay. Hey, say hi to your future self in the video.
What do you mean?
You're on, I'm in the middle of one of the lessons right now. Say hi to your future self.
Oh, hi. Well, how would it be my future self?
Because you're going to watch this video later.
Maybe I'll watch it now.
Well, I haven't posted it yet.
I know.
The more you talk, the longer this video gets.
Oh, okay. What were you calling about?
You're not going to say hi to your future self?
I said hi.
You didn't say it very enthusiastically.
Well, hello, future me.
Alright,
Yeah.
well.
What'd you call me for?
So let's go ahead and move our 5 over, subtract a 5 from each side. So what's nice about this is now we have all our x's on one side and all of our non-x's on the other. Equals 4. Alright, how do we combine these three x's? What's our rule for adding and subtracting fractions? All have to have the same denominators. What are our denominators right now? 3, 2, and an imaginary 1 over 1, which means we have to find the least common multiple of 3, 2, and 1. What is that? That's 6. We got to get all these equal to 6. We multiply 2 over 3 by 2 over 2, which gives us 4 over 6x. We got to multiply 1 over 2 by 3 over 3, which gives us 3 over 6x. And we got to multiply 1 over 1 by 6 over 6, which gives us 6 over 6x. Don't forget about the negative. Equals 4. Add these up. 4 plus 3 minus 6 gives us 1 over 6. Don't forget the x equals 4. Multiply each side by 6. X equals 24. If you don't get it, slow down and see if you can figure it out. All right, we got some tricky looking ones, not a problem. Let's start by clearing our fractions. So what are our denominators? We got 4, we got a 1, we got a 1. So what's the least common multiple of 4, 1, and 1? 4, so we just multiply everything in this problem by 4. Just put parentheses around everything, 4, 4. This cancels, we're left with 2x plus 3 equals, distribute the 4, 4x plus 24. We got to get all the x's to the same side. Let's move the 2x over, minus 2x, minus 2x. 3 equals 2x plus 24. Get the 2x by itself, minus 24, minus 24. Little do you know, I've been gone for over an hour. Okay, continuing. Where were we left off at? I don't even know. Alright, looks like we were at 3 minus 24 gives us negative 21. Is that right? I don't know. Someone check my work. Equals 2x divided by 2 on each side gives us negative 22 over 21 over 2x. Or if you want, you can say negative 10.5x. Either way. But I prefer the fraction. Okay, let's take a look at the one on the right. Once again, we're going to clear our fractions. What are our denominators? 2, 1, and 1. So we'll multiply by 2. We got to multiply each whole side by 2. So 2 times 2, and then this times 2. These cancel, and then we got 8 over there. So we got 3x plus 2 plus 8. And over here we got negative 14. Combine like terms on the left. 3x plus 10 equals negative 14. Subtract 10, subtract 10. 3x equals negative 24. X equals negative 8. Great. All right, number 10. Let's clear our fractions. What are our denominators? We got a 1, a 2, a 3, and a 1. What's the least common multiple of 1, 2, and 3? It's 6, so we'll multiply both sides by 6. We got negative 66 over here. We've got 6x. 6 divided by 2 is 3x. 6 divided by 3 is 2x. Equals negative 66. Forget that, I accidentally wrote it twice. Combine like terms. We've got 11x equals negative 66. Divide by 11, divide by 11. X equals negative 6. And then over here, let's clear our fractions. We got a 1, a 3, and a 1. Multiply everything by 3. we got 3x plus 2x equals 45. Combine like terms, 5x equals 45. X equals 9. Alright, those are the practice lessons. I'll see you in the next video. Bye!